We will show you how to convert a car alternator into a high-efficiency brushless motor. Stay until the end of the video to uncover the secret. Brushless motor development. We will disassemble this old car alternator. We will begin by removing the carbon brushes. We will dismantle the pulley. And remove the diode rectifier. We will continue to fully disassemble the alternator. Here we have the coil. We will strike the shaft to extract the rotor. Now we will remove this bearing using this specialized tool. We will also extract the brush holder assembly. We must cut all these iron teeth-shaped pieces. We must also remove all the copper winding. We will machine the rotor surface on a lathe. We have fabricated this special component to adapt neodymium magnets. We must secure this component to the alternator rotor. To do so, we need to tighten these two screws. On this component, we need to attach all these magnets. We will glue them with cyanoacrylate. First, we will attach all the magnets with north polarity on their outer faces. We now have the first row of magnets with north polarity. We will continue attaching the second row of magnets with north polarity. This process is quite delicate. We will now proceed to attach the magnets with south polarity. They should be alternated north-south, north-south. We will cut this plastic container. We will also trim this CD. We will insert the CD into the magnet assembly slot. We will secure it with insulating tape and seal it with hot glue. Now we will place the plastic piece to create a hermetic enclosure. We will use this two-component epoxy adhesive to compact all the magnets onto the rotor. We will pour the epoxy adhesive slowly to avoid air bubbles. We will allow 24 hours for the adhesive to cure, and then we can remove the plastic enclosure we created around it. We will bend the blade slightly to extract all the plastic. We will now machine the rotor on a lathe to achieve the exact dimensions and ensure it is fully balanced to prevent vibrations. We will reposition the blades correctly. And this is the magnificent result. We will thoroughly clean all the components. We must take great care not to damage the copper winding. It is now restored to like-new condition. We will now assemble all the components. We will insert a bearing, We will now install the copper winding. And with great care, we will insert the modified rotor. We will place the top cover. And we will fasten the assembly with all its screws. We will also install a pulley. We will strike the shaft to align it between the bearings. And now we have the motor fully assembled. We will continue with the electrical connections. We will solder these wires to each end of the 3 internal coils. First, we will tin the ends of each coil. And now we will connect them in a star configuration. We will protect the connections with heat shrink tubing. This is the completed star connection. We will now solder the motor power supply wires. We will also cover the connections with heat shrink tubing. We will secure all the wires firmly with cable ties. We have bridged the ends of the 3 coils in a star configuration. And these 3 wires are for powering the motor. They originate from the other end of each of the 3 coils. We will strip the power supply wires. We will attach electrical terminals. This is the brushless controller we will use to test our motor. It has a potentiometer for adjusting the motor speed. It operates with a direct current voltage of 18 to 55 volts, and it supports a current of 30 amperes. This is the output port where we will connect our brushless motor. You can find the purchase link in the video description. We will use this power supply to start the motor. This power supply operates with 230 volts of alternating current, and we can adjust the output from 0 to 60 volts of direct current. We will connect the plug and attach these wires to the brushless controller. The negative with the black wire and the positive with the red wire. We will turn on the power supply and adjust the output voltage to 55 volts. When we turn the potentiometer, the motor begins to accelerate. We have reached the motor's maximum speed. It has such high torque that if we accelerate suddenly, the motor jumps. It is very quiet and very powerful. With a more powerful controller, it can achieve 10,000 watts of power. The great advantage of this brushless motor is that it is also an electric power generator. That is, if we move the motor shaft, we will have an electric current in the motor cables. With this electric generator, we could build, for example, a wind turbine to have electricity in a house. We will measure the motor speed. To do so, we will use this non-contact digital laser tachometer. You can find the purchase link in the video description. To take the measurement, we will attach a piece of reflective adhesive. Each time the laser detects the reflective adhesive, it counts 1 revolution. In this way, it calculates the motor's RPM and displays it on the digital screen. Reaches a maximum speed of 2,875 RPM with 55 volts DC power supply to the controller. When the controller is powered with 55 volts DC. If we want to reverse the direction of rotation of the motor, 2 of the 3 power supply cables must be interchanged. We will now connect the center wire to the end. We will turn on the power supply again. And now when we turn the potentiometer, the motor rotates clockwise. The maximum speed remains the same. It has significant power. Leave us a like if you enjoyed this video. It will help us continue creating content. Thanks to all of our members for their support. Become a member to support our videos. Share this video and join the energy revolution.